In the drawing tower facility is where we make all of our fibers. Everything starts with a preform at the top of the tower, as we can see glowing there, which goes through the furnace, which heats up the fiber to 2000 Celsius, and then the fiber is drawn to a specific size, in this case a 125 cladding diameter fiber. Then it goes through the coating appliers. Coating is applied to the fiber, and then the fiber is collected into this little drum that we see here. So we can see this process is done automatically. All we have to do is to find the right diameter, and then the tower will do the automatic process of collecting the fiber. Can be like 1, 2, or many kilometers.
Oh, hey.
Hello.
You again.
Welcome to our lab. This is the fiber fabrication lab. You have seen the tower before, and as you can see here, we have many fibers. Most of these fibers are actually made homemade. So I'm gonna show you the a few setups that we have in this lab. As you can see, there's fibers everywhere. Of course, fiber lab, right?
Makes sense.
So I'm gonna show you a few setups that we have for fiber characterization, which is important. You have seen the tower, which where we make the fibers for different applications, telecom, fiber lasers. But we don't only make the fibers; we also use them. And in order to use them, we actually make some devices and characterize them as well in this lab. So here we have one of the devices that we make. So what is this? This is actually a Photonic Lantern, which is used for mode multiplexing. So what it is, it's a set of fibers inserted in a capillary, which is then tapered down. And then in order to characterize this device, so we have this setup here, which what we have here is we have a laser, and then we have a switch. This is actually a 6-mode device, so we have 6 input fibers going out of this switch. And then it goes through the lantern, which is already packaged here, and it's spliced to a few mode fiber that support these 6 modes. So we have to characterize the modes of this device, and so we can see here in the camera after the free space propagation, we can see.
So this is actually on.
It is on,
okay, it's on. Okay, just slow, slow. Okay.
And then we can actually check all the modes profiles at the output of the few mode fiber. You can see we go one by one, and we excite different modes in the few mode fiber, like LP21 modes, this one and this other one, and finally the LPO2 modes.
That's quite impressive.
And so if you want to have something like this, even without propagation through the few mode fiber, and if you want to use it for some other experiments, you can actually just have it into a ferrule, and then you will have the output of the Photonic Lantern just like this.
Terminated properly, okay.
Terminated, yeah, without going through the few mode fiber. So what is important in any optical fiber devices lab is to have the necessary tools for characterizing the fibers and the devices that you make. So in this lab we actually have different microscopes. Like this one is an optical microscope, and with this we can measure the features on some of the fibers in a very fast manner, so that you can optimize for the drawing process and things like that. And if you want something more specific, then you will have this tabletop SEM, where you can actually measure the fibers. If you want to measure the microstructure of each fiber, like in this case, where we work on hollow core fibers like this one, you can actually measure them very precise using this tabletop SEM. If you want to measure the thickness of each of these optical fibers. And not only for these fibers, we have plenty of other fiber designs as well that we can actually characterize, and it's very important to have these tools as well.
Alright, here's our holography setup. We have our 40 milliwatt laser at low infrared coming in through here.
Into our Photonic Lantern again. Okay.
Yeah, so we
looks good.
the fiber splitter, one becomes the reference wave, the other goes through the Photonic Lantern, so we can profile it.
Okay.
And right now we're only testing one of these modes.
Okay.
And as it comes in, we put it through a polarizing splitter.
Okay, sounds good. Then you recombine it and see it on the camera, no?
Right.
Looks
so
good.
Look here. You can see our two polarizations, the reference wave going this way.
Okay.
Here's a K-space transformation. We crop it and we get this, and this is our reconstructed image.
Amplitude and phase.
Of
Okay.
amplitude, and then here's our face.
Cool.
Yes.
That looks quite dope. Thank you very much.
Sweet, thank you.
Here we have a setup to test what's the behavior of pulsed lasers propagating through nonlinear media like a gradient fiber. So the first thing that we have is the pulse laser that we're shaping here with an SLM. And then we're coupling all the different waveforms that we can generate with the SLM in the gradient index fiber that is the one that is mounted here.
Okay.
So for example here we can see that only changing the part that is printed in the SLM, we're able to excite different kind of modes in the fiber. So for example this is one kind of mode. This is another kind of mode. And then the thing is that we want to analyze what the behavior of the light when it's propagating through the fiber. So we have mounted a system that is pretty similar to the one that we are using to excite the fiber to decompose what's the model content of the beam in the output of the fiber. We have another SLM, and basically we are coupling the light into a single mode fiber, and we are testing what's the power that is coupling into that. Also, for example, here we are able to see the near field of the beam in the output of the fiber. And for example, also we can finish the analysis using a spectral light modulator
Okay.
like this guy that is over here.
Okay. Thank you very much.